Hi, I'm Assam, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 31, questions 85 to 86. In this unit, we're going to take a look at a figure that summarizes some data about the age-specific mortality rate of elderly people in the US. Now, lucky you, I've got it written here. The graph actually shown in the unit stimulus is not required to answer, well, question 85. You just need some simple arithmetic and deductive reasoning. This is because if you actually pay close attention to what the unit stimulus and question 85 is telling you, it's telling us that the graph is based on application of Gompertz law after the age of 95. However, the question 85 is asking us about applying this rule from age 80. So the graph or the figure we see there in the unit stimulus, we can't apply for question 85 because it's a completely different, the data's been played around with specifically for Gompertz law after age of 95, whereas in 85, we're looking for applying Gompertz law from age 80. So the graph would look different. So that's why we can't use the figure. So if we take a look at question 85, it says that, suppose Gompertz law is applied to the data from age 80, and the mortality rate is 0.1, the probability of a human dying in a particular year doubling every 5 years. So which of the following is closest to the probability of a 95-year-old person dying before 96? Now, if you actually looked at the figure that they provided, you might just say, oh, let's take a look at 95, therefore it's going to be 0.4. But that's not correct. Remember, the figure they provide is for applying Gompertz law after the age of 95. We want to apply from the age of 80, so we can't use that figure. The data is not what we want. It's a completely different figure, different values, different numbers. So how do we approach this? So let's just say at age 80, so we've got our age, and we've got our mortality. So we're told that at age 80, the mortality is 0.1, and we're also told that this doubles every 5 years. So every 5 years, it's going to double. So 0.2, and then what's the chance that the person, the probability of a 95-year-old person dying before 96? So let's go 90, 95, and we'll stop there. So 0.4, 0.8. So that's why our answer for 85 isn't 0.4. Well, I guess it's not going to be these either, but that's why it's 0.8. The trick was to read, comprehend what the information was telling us. The figure they provided was for Gompertz law after age 95. 85. The question 85 is asking for Gompertz law after age 80, so it's a completely different figure. So don't even worry about that. So that's why 85 is A. Now 86 is a bit of a philosophical question, but we can kind of use a process of elimination here. It says, which of the following best helps explain why the observations differ from expected in the figure? So 86, we have to use the figure here. We can see that when we apply Gompertz law, we expect to see a higher mortality, I guess, after the age of 96, but we don't see that. We see that the mortality is a lot lower. Why? Well, A says older people are frailer than expected. That's kind of the opposite. It doesn't explain why they're dying. They're not dying as much at these older ages. If anything, that's explaining why they're actually dying. So A is incorrect. B says mortality rate varies randomly with age. Again, that's not explaining why we see the observed trend is lower than the expected. If that was true, mortality rate varies randomly with age, our line wouldn't be, I guess, this exponential going up like this dropping. It'd be like all over the place, wavy. So that's why B is incorrect. C says people die of conditions other than old age. Well, I mean, that is a true statement, but it's not explaining why we're seeing observed that's a lot lower than expected. So it's not answering the question, even though it's a true statement. So that's why C is incorrect. So D says people surviving to old age are more hardy than expected. That's obviously a process of elimination. That's correct. It's true. Because keep in mind, most people, they don't live to 90. Especially in Australia, the average life expectancy of Australian is about 80 years old. I mean, individuals who live past this age, they're more likely to possess immortality genes, or are just pretty much lucky. I mean, there's lots of research going into why people do live longer. It could be genetic. It could just be luck. I mean, if you don't live next to crocodile-infested waters, you're less likely to get eaten by a crocodile, so you're more likely to live longer. Diet, so many things that can affect these numbers. So yes, it was a bit philosophical, but if you did go through process of elimination, you could have got to the last answer. So if you're still finding it difficult to comprehend this unit or to understand why we did have to use the figure, or if you have any other questions, you can post them in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.